like Europe Geophysical Society, Indian Mathematical Society, American Society of Mathematics, and etc. MAM has conducted various MHRD workshops in collaboration with the researchers of Taiwan, Slovakia, and Russia. Last but not the least, she has also conducted a number of FDPs, short-term training programs, international and national conferences in the computational fluid dynamics, role of women in technical education. She has also served as the dean for international affairs and also as a resource person for the national conferences and international conferences. With this, I take the pleasure of inviting a renowned professor, Dr. Rani ma'am, to take over the session and share her valuable thoughts on role of engineering in emerging technologies. Over to you, ma'am. Thank you.
Yeah, thank you, madam, for the detailed introduction. Yeah, let me thank the management for giving me the opportunity to speak among the young minds, the engineering students who are going to build the community in the coming days. So I want to thank the head basic sciences and humanities, who along with Dr. Raf Sayed sir, so who gave the opportunity to present some of my thoughts as Ismat Aziz madam said in front of you. So I put it is like a combination of emerging technologies as the theme of the meeting is said here. So I will start from the beginning, how it is evolved and what are the works which I have contributed to this scientific community till now, and then what is going on in these areas by citing some of the works from prominent universities in the world, and then what the industry tells about mathematicians, how they are recognizing us. At the end, I will go for the need, what we can contribute to the humanity as a whole. With that, I sum up my presentation. I hope you can see the screen.
Yes, ma'am, we can see that.
Okay, so the title of the talk for today's lecture is Role of Mathematics in Emerging Technologies. So technologies means what? Let us see that one and how we progress. Okay. So I will start with this slide. As Karl French Gauss, the German mathematician, said that mathematics is the queen of sciences and number theory is the queen of mathematics. Now, all over the world, we are playing with the numbers, I can say, because artificial intelligence, machine learning, everything is with the data. Whatever data we have, what the numbers, what the beauty they are telling to us, how we can interpret further, how we can understand further from this mathematics. Mathematics means now, as per Gauss theorem, etc., we have seen the German mathematician highlights this, how the prime numbers plays a key role in number theory. So if you take up, I have got this from the one of the WhatsApp message only. If we take coffee bean as f of x and f dash of x is this powder, coffee powder, and f double dash of x is making the coffee. So in day-to-day life, every time we are coming with the mathematics only. So the second order derivative is this one, the coffee. So how we can say that without mathematics we can live? So the how the technology is growing. Okay, with respect to the years also, the website Canterbury Communication WordPress shows that technological accelerated change. They call technological accelerated growth. Okay, so in from starting from 1400s to 2050, they have shown this graph. Initially, I have blown up and I want to show this one. So initially in 1400s there is a printing press. Then later the telescope showed its presence, and then steam engine, telegraph, telephone, everything come in this 1700s to 1800s. Later, in the moon, we have landed. The humanity has put its footstep in the Mars, in the moon. Then later, in this, starting from late 1900s to 2000, in this years, there is so much technological growth is happening, like microprocessors, word processor, even programming language. The starting one is MS-DOS, Apple Macintosh, Windows, websites, DVDs. Now we have the 3D chips, we have GPUs to calculate. Even I can say that when I have taken one calculation, it took 15 days without any power interruption to complete one calculation. But when I have used message passing interface, MPI, when I have used this MPI in my calculations, it took only half a day to complete the calculation. So now you can say that how much technological advancement has been taken place in everyday day-to-day life. Even with respect to mathematics also, it is linked with the programs. Whatever programming language, if you know, it will come like a support for you. If you don't know also, the Mathematica, MATLAB, Maple, so many tools are there handy for us. Once we write down the equations, if we give the input to the MATLAB, Mathematica or Maple, nowadays every engineering student is learning. In NIT Warangal, I can see very openly that even from the first year itself, they start learning this MATLAB codes, Mathematica, Maple codes, because every student must have little bit of awareness to solve this one equations. Let us blow up this chart and see. So when it started from 1946 to 1964, the people who are in this era are known as baby boomers. So how they are using the technologies, that I will project in the next slide. Coming to the generation X, they are between 65 to 80, and millennials. So they only contributed a lot for this technological development. They are classified in this era 1981 to 1995. Then after that, the young generation, very young generation, 1996 to 2010. Of course, they are mostly using it and they want to progress further whatever has available in the society. So this is one video. Just see how popularly the programming languages over the years have taken their role. So initially, Fortran was dominating formula translation. Fortran is nothing but formula translation. So that is what dominating. Later, over the years, as you can see that the clock is moving on, how it is getting going back. One second. I'll move forward because it will take so much time to understand. You can see that Pascal is slowly coming up and dominating. At the end, nowadays, as you were aware of that, Java is dominating too much. And see, in 2002, Java is dominating too much in comparison with other languages. In the beginning, we have seen Fortran language, which is dominating, but later, now Java and JavaScript is coming up, along with other programming languages like C, C++. When we come to 2016, is still Java only topmost. Later, Python is coming up. Nowadays, Python and R programming are very famous. Python and R programming. These are the two languages which is ruling the programming world. Yeah. So nowadays, lot of courses are going for Python. As I said before, Python is ruling along with R programming. Even for our some of our research works also, we have started using such type of languages. Okay. Coming to the social media, how in the social media means all of us come across about this WhatsApp, Facebook, even Google also I can tell. So much of information we are getting from this social media. by generation. In the last slide, I have showed the generation baby boomers, generation X, millennials, generation Z, and overall globally. So among this one, you can see very well that the current generation is using much of the social media. This I have taken from the Global Web Index. They have given this statistics that the current generation, Generation Z, is heavily using the social media. So they have more responsibility to develop the technologies to connect the people. Social media means it is connecting the people. So growth in social media, time is slowing down. So with respect to if we, in the previous days, time consuming is so much. If you want to get a small information also, we have to take so much time to get that one. But because of the growth in social media, time is slowing down. That is the information, overall information the Global Web Index has given. And the major role is played by this Generation X. Even you can see that their usage is 2.55% in comparison with other generations. In Asia Pacific, average daily social media time usage with respect to the region also, it is given to be Asia Pacific is in the major role which is playing. So now we are in the era of fourth industrial revolution. We are in the era of fourth industrial revolution. We'll see the exponential growth in technological development. So I think the organizers well aware about this one. That's why they kept the National Science Day with respect to this topic, resulting in rapid changes to business and society. Why it is more specifically written as business means nowadays you are aware that even the online classes are taking place, online meetings, work from home. So much of culture is coming up in the business. If the business don't accustom with that type of technology, survival is very difficult for them. So business has a lot of things to do with the technological inventions it should take out. Next, society also playing a key role in this one. So these are the two major things which is playing very important role in the technology. So accelerating growth in technology, as I said before, compared to the previous years, previous decades, now there is a beginning of cyber physical systems in this one, especially from 2007 onwards. This started up and it is moving like anything so rapidly. With this background, I planned my talk as the introduction, why we need this technological growth with respect to mathematics. So that is what I planned in the introduction session in the coming slides, and the applications. Whatever the mathematics I have used in my applications with respect to the societal needs, and digital media, and how I can contribute to the society and nature, that I want to project here, along with the teaching and industry community from MIT, Oxford, and Harvard universities, General Motors, and General Electrics. With that, how we can understand what is the modern technology requirement. That is why I put here need. So let us start with that. So fundamental idea, there is a fundamental significance to the mathematical way of thinking. So it is very clearly classified mathematical way of thinking. Why it is said like that? Because it is a systematic one, reproducible and transmittable knowledge. These are the very fundamental things every human being requires. So when we think about briefly, mathematics provides methods for organizing and structuring knowledge so that when applied to technology, it allows scientists and engineers to produce systematic, reproducible, and transmittable thinking. That is why they say that this is a keyword, mathematical way of thinking. The next chart shows that what are the key processes involved in this one, thinking processes involved in this one. Read, think, say, and draw. So this is what the basic, I see that the engineering curriculum is designed like that. Then collaborate with others. This is the most important part. If you collaborate with others, as your head basic sciences said that nowadays everything is becoming interdisciplinary. if we circle ourselves to our own field, then growth also is limited to us. Then estimate the things, then mathematize. Okay, this is mathematical model. I will use some math methods I know to convert my thinking into something more mathematical. This is more essential. If you see any physical process or any experiments or any observational things, how you can convert into mathematical models. So this plays a key role in this, and how you can apply your knowledge of mathematics. Like in the first slides I have showed, f of x is a coffee bean, then f dash of x, f double dash of x. Second order derivative also has some meaning. Like that, if you can able to draw something from the physics or chemistry, whatever you say, into a mathematical model, how to solve that one is the second part. So iterate. Once you solve that one, exactly we may not get the solutions. It may be the analytical solutions, whatever we are seeing in the first year courses like Laplace transform, Fourier transform, solutions. So if you don't get such type of solutions, then you can design your thinking. What else I can do further? How I can proceed further? I will try something, revise my process. This is the most important thing. With this revision of the process only, artificial neural networks comes into place. ANN we call in short. ANN and machine learning. So try again. So you can see in one of the problems which I'm going to show you, it keeps on trying until it reaches the desirable accurate results. So ANN has a major play with respect to the iteration, design thinking. So after getting the result, whether these results give me any sensible way of results, that is more crucial thing. So we used to say that physically meaningful results only we want. I will ask myself if my answer makes sense. I will ask myself if my answer is reasonable. How I do know? So whether it is reasonable or not. So we will go back to the nature, our experiments, our observational data, whatever we have in hand, and we will move back and we will see that results. So this is the general process of mathematical thinking. So the role of mathematics. Mathematicians often say that the essence of mathematics lies in the beauty of numbers, figures, and relations. Even in artificial neural networks, in machine learning, everything is based on the relation between two nodal points. They call those nodal points as neurons. In different subjects, the terminology is different, but the idea is same. So hence there is a truth in this one. Together with the experimental method, as I said before, mathematics forms a conceptual scheme on which the modern science is based on, and which supports technology with close interactions among them. So how can I put this in a pictorial form? You see, the real world problem or situation is taken up, and then with some simplifications, we can't able to solve the real world problem exactly as it is. So we will do the problem formulation by simplifying the real world model. Then we go for the mathematical model. From here we start 1, then 2, then 3 mathematical model, transforming this to a solution with the model. It can be very exact solution or approximate solution also. It can be approximate solution also. After getting the solution, again go back to this real world problem for the validation. So it is like a routine one. 1, 2, 3, 4, again 1. So you keep on iterating this. So like ANN is also doing the same thing. Even mathematical models like Jacobi iterative methods, even there also, until you go to the real world solution or some approximate solution, we keep on moving to this one. That is why it is given like this. Understand first, then fluency in that subject, then solve the problem, and then with proper reasoning validate that one. So these are the 4 steps involved for any mathematical model or any problem in general. Now, what is the relationship between mathematics and technology? So they are hand in hand. You cannot take one outside and the other is there. Modern technology would be unthinkable without mathematics. We can strongly say that In the coming slides, I will show that even in the small things, from clean air or clean water to medical research, everywhere mathematics plays a key role. The relationship is reciprocal. Since mathematics also needs technology, why? Today mathematicians use computers, as I said before. For my work itself, I am totally dependent on programs, computers, not only for the calculations, but also for numerous other tasks, including the search for proofs, validations, counter examples. Even I can say that even for discussions, we need the computers. Without that, now moving further is like impossible. So now let us move to the second part of my talk, that is about the applications, where we can apply this one so that in a better manner we can understand what is the technology, modern technology needs. I have taken this Reynolds number, which is class 11th physics, mathematical properties of fluids. Okay. How it plays a crucial role for the flow past a cylinder. So this one in University of Canterbury, South Africa, they did simple circle. They have taken circular one, and they started simulating if the velocity is given here, how it plays a key role. In this one, I want to point out here the Reynolds number. You see here, the Reynolds number is defined as this. Reynolds is a scientist who has defined this one. So rho and mu already we know. Rho is a density, mu is a viscosity. Both of them depends on the fluid property. If you take the blood, those two values, rho and mu, will change. If you take water, it will change. If you take air, it will change. So rho and mu are basically about the fluids. And D is the diameter of this circle. Whatever he has considered, the diameter of this circle. So it is called as characteristic length. That is, it depends on the geometry. So we have considered the fluid, we have considered the geometry, and here is the velocity. Here is the U is the inlet velocity. See, diameter of the cylinder, and U is the inflow velocity. So based on the inflow velocity, how the path of the fluid is getting changed. So you can see here. So from the school mathematics itself, how much things we can do. So if the velocity is less, we are getting the smooth lines over the cylinder. Such type of problems has a prominent role in the design of cars, aeroplanes, what not to say. So many things we can observe from this. If I increase the velocity of the incoming fluid, then of course you can see here the presence of the vortices. This disturbs the flow pattern. If we move forward, there will be a pressure. So that is why this aeroplanes, etc., even the motor vehicles especially, needs such type of knowledge. So here near wall, the fluids are slowing down. So you can calculate dx by dt. This is the usual formula we used to get for the velocity along the x direction. So what is happening there? Based on this, based on the velocity of the fluid particles, the separation region is clearly identified and it has been proceeded further. So what mathematics I have done is, if I take a vertical cylinder like this, if I heat that cylinder, how the fluid particles are moving. So heated cylinder, slowly it is moving. Okay. So this is the thing. So to overall, I can put it like some picture. We have physiochemical things. We have the nature, which is built up of plants and animals. And we have the immediate surrounding things as human beings. So there is a need to study about all these three things together also. To live very peacefully, to have a very collaborative or smooth work, we need to understand all these three things. How we can understand? It all comes from the nature. We all put together, we can call it as nature. So from the nature, what we are doing? We are observing. We are observing the things. Lot of observational data also available. With respect to WhatsApp also, you can see so much of data. With respect to Facebook, Google, everywhere, even Amazon, Flipkart. So like that, if you take that, even there also observational data with respect to the human beings. With respect to plants and animals also, we are getting the data. With respect to physics and chemical things also, we are getting the data. So everything we are putting together as a nature, then observational data, and it can be reproduced with respect to the experiments, lab experiments. In our plus one, plus two classes, so many experiments we did. So with respect to accounts also, if this Sensex market is moving up and down, how it is moving further? For that, we did so much of statistical analysis also. So that things we can put together in numerical and analytical way. So now here only this computer plays a key role. So because sometimes if I want to do some experiments, it takes time, it needs lot of manpower. So many criterias I can say. Sometimes with respect to the nuclear industry, they can't perform such type of experiments. They are hazardous. So many deaths also has happened. Then they came back and they relied upon the numerical results. As I said before, we have to depend on the output of these results. How we can validate? Either through experiments or through observations or through with respect to the nature itself. So now let us see more detail in this one. So just now I said about the nature. This is a wake behind the ship. When the ship is moving forward, you can see in the ocean such type of, we call this as vortices. We call this as vortices. With respect to velocity, only these vortices are produced. Velocity of the fluid. Which fluid here? Here it is a water. Here it is a water. Water is the fluid. When the ship is moving forward, how these things are formed? Which type of mathematical model I can write for this? So to reproduce this one, the immediate one, they go for the wind tunnel experiments. This type of laboratory things are known as wind tunnel experiments. That means in this tunnel, they set up their cameras, how to imitate this flow here, etc. It will be a huge labs, okay, in general. So in this one, they have to create such a type of environment which is similar to this. So, but in mathematical way, I have used the equations to reproduce that one. So when the ship is here and it is moving in this direction, so what is happening near this step one? What is happening near this step one? I can see very much the fluid velocity is moving back in this, very close to the side walls and near the step walls and close to the floor also. Such type of things can be observed in computationally. So already I have introduced what is a Reynolds number. Based on that number, I have got such type of three-dimensional data. Okay, how it is useful to the industry? So motorsport aerodynamics, there also so much of work is going on and controlling is taking place. You can see further here importance of aerodynamics here with respect to the year 1950 to 2000, how much technology has been improved with respect to the moving vehicles here. So dynamics means moving things. With respect to aero means only with respect to air they consider these type of studies. So racing cars with aerodynamic downforce. As I said before, when the velocity is moving backward, then lot of pressure is generated and it will object the movement of the vehicle itself. Racing cars without aerodynamic downforce. So these are the observations they made and lot of changes have been taken place. That's why in the racing cars, you can see the side skirts. So you can see the side cuts. Side cuts prevent high pressure air around the car from disturbing the low pressure underneath the car. So this is also a major advantage or technology came into picture. One of the example we can see. Even this type of wings also. This type of wings plays a different role in airplane, but different role in the racing cars. So how to put this type of wings? Where to put? So much of mathematical analysis is required. So aerodynamic design methodology depends on the CFD, that is computational fluid dynamics, wind tunnel experiments, and devices are assessed and approved for racing. After these two things only, they are approved. Nowadays, you can take so much of commercial softwares are doing such type of work. Coming to the medical research, microcirculation in liver. So I have been asked to do research in Taiwan about the flow inside the liver, such that how the cancer patients can be treated without pain. That is, so much of side effects are happening because of these medicines what they are getting injected. So to understand that one, first I have to understand how the flow is taking place in the liver. How the flow is taking place in the liver. In mathematics, we have come across about these hexagonal structures. These hexagonal structures. So the beauty of the liver is it has two inputs. Two inputs. One is from the smaller one is artery, hepatic artery. Whatever we inhale the air, that is coming inside, and whatever food we take, that is also coming inside in this portal vein. So it is moving and coming down in the hepatic vein. This is known as outlet. So we have the boundary conditions, two inlets and one outlet. And further, after taking out all the impurities, they are filtering into the gallbladder. So there are two forward flows and one backward flow. I have taken up this as a study. Even no data or nothing is available, so I have to directly interact with this Taiwan University Hospital. That medical doctors, after the surgery, we used to sit together and we analyze that with what velocity this fluid is coming. Here blood is a fluid, how it is coming, whether they are mixing or not. Two inlets are there. So same blood only coming with different properties. Here this is oxygenated rich. This is O2. One blood is oxygenated rich, another blood is nutrition one. So after this, they are moving and going out. So two inputs and they are moving out. So what is happening exactly in this region? So nobody has told me that how it is happening, what it is there. So much of research I have done. Later I came to know that there is an intermittent activity. When we inhale and exhale, the fluid is moving along with that. When we exhale, this fluid is moving. Nutrition rich blood is moving. When we inhale, then oxygen rich blood is moving. With that one, I have simulated that mathematical model in this way, taking only one part of the liver. These are the liver cells, how they are acting in different areas with different behavior. Then we have published this result in Journal of Biomechanics. So the medical doctors itself appreciated that how things are moving inside this one. So this is nothing to say about the modern technology. What we have to do is how things are proceeding, what is happening inside. Let us move and go in depth and understand the things. So the next one, coming to this is the project along with my student Divya, we did, and the collaborators are from BRNS, that is Board of Research in Nuclear Sciences, Board of Research in Nuclear Sciences and others. So they used to give us the data from the nuclear industry. Actually, what is happening is nuclear reactor is in the center. Around this nuclear reactor, there are so many pipes. There are so many pipe structures to cool the nuclear reactor. So these pipe structures are made up of carbon steel. These pipe structures you can see here in pipes and pipe bends. Flow structures are made up of carbon steels and water is flowing here, D2O. Demineralized water is circulating in these pipes. In these pipes, so what is happening here? This is a steel and it has a oxygen, D2O as a oxygen. So both of them are mixing together and there occurs a corrosion. So because of the corrosion, sometimes there is a break. There is a break in the pipe. When there is a break in the pipe, so much of radiation is coming out and it is affecting the humanity. So where this break is occurring, how we can detect this one? So based on the first order derivative of velocity, we can calculate at which point this breakage can occur. That is known as wall shear stress. Mathematically, it is known as the wall shear stress. That's what it is shown here. Here is the metal. Here is the pipe metal is there, and water is flowing here. So ferrous ions local concentration, ferrous ions in equilibrium concentration. So the solution is water. Something is happening in this oxide layer. Something is happening. What is happening? That's what the problem given to us along with the scientists from Board of Research in Nuclear Sciences, Baba Atomic Research Center, Mumbai. So these are the basic equations we have taken, and we have used finite volume method. We have used finite volume method. Here is the velocity. Here is the velocity, and the first order derivative of the velocity only gives the location for breakage. So different types of geometries we have taken. Different types are given to us. We have considered that, and we have validated our results. You can see the red regions. Here only the break is coming up. Here only the break is coming up. So exactly we have showed that the break can first occur at the topmost region of the pipe. Exactly here only the first order derivative shows the negative results. It is coming back. The velocity is coming back. That means so much of pressure is accumulated. Because of the pressure, it draws everything from the above point of the fluid, and again here also pressure difference comes, and the breakage is occurring here. So secondly, the breakage is occurring here. Like that analysis we have done with the help of those mathematical equations. The second one currently now I am doing with respect to the society using Google Earth Engine. Google Earth Engine. Nowadays you are coming across about the Google Maps. So much of data it is showing, and what we can do further. So we started with the Renuka Lake in Himachal Pradesh. I have gone there for the training in ISRO. 2019, in ISRO, I have gone there. So what type of contribution I can give for them? Then I've gone through this Google Earth Engine, which gives me the data through the satellites, and you can download that. From the data, what we can do? Then I have taken up this Renuka Lake, and clearly you can see the shrinking of the Renuka Lake over the years. This is in 2014, this is in 2018. This is in 2018. The down figure is in 2018. This is in 2014. Using the Python programming, this data has been used. The data from the Google Earth Engine has been used. The data satellite is Landsat 7. Landsat 7 and 8. We have used this Landsat 7 and 8 data to predict how much the shrinkage of the wetlands are happening. Today also they said that in one of the seminar, wetlands are the kidneys of the earth. They filter everything, and they gave us so much clean air and clean water and habitat for so much of plants and animals. So many things we can get from that. So this type of work I have carried out, and one of my students also working in this one. So here also you can see how much that shrinkage of the wetland has taken place. Now we are working with the Paka Lake in Telangana. So it is also categorized internationally. It is going to be categorized. Paka Lake is going to be categorized internationally as a wetland. So a lot of habitat is going on. So it is our responsibility to understand and preserve the nature. That's why coming to Sir C.V. Raman's quotes, in the history of science, we often find that the study of some natural phenomena has been the starting point in the development of new branch of knowledge. So in order with this, some of the examples which I have worked have been shown to you. So coming to the digital media, this is also digital media. Mathematics as a tool of the media can influence the values, beliefs, and ideas of its readers and listeners. This is the ultimate goal for the mathematics, I can say. So it influences the values, beliefs, and ideas of its readers and listeners. So as a result, students and consumers of information must learn how to recognize sound and usable data in a wilderness of numbers. You can observe this YouTube video. How the mathematics is playing a key role here. When mathematics meets digital media marketing. Yeah. Yes. So I was here. So you can see that with the human beings itself, so much of work is going on. So whatever data we are sending, with that, how they can get some information using mathematics. So that's what here artificial neural networks. That's what I was telling. So input as that video they are telling each day I am sending so much of information. Otherwise, in my calculations, in my specialization, computational fluidamics, I am getting so much of output of results. Output of that will be given as an input for this from CFD, I am getting the so much of results and I will give that as an input for this. Then I am getting some information together. If I analyze them together like this, if they are connected with the hidden layers, like a straight line, if I use y equal to mx plus c. This form y equal to mx plus c, and this c is known as a bias here and mx weight into input here. So my inputs are x and weight is m. Weight is m. In a more crude way, I can see this artificial neural networks like this. Y equal to mx plus c. In straight lines, every information is connected. Later, what they assigned is their straight lines will not work for us. They can't be straight lines. The information is not connected in terms of the straight lines. Then they went for the exponential functions called sigmoid function. Sigmoid functions. The notation is this one 1 by e to the power of minus x. Okay? Like this sigmoid function. If you have a sigmoid function, that is a nonlinear function, then how the information is passing through this hidden layers. That is a job we have also taken up, and one of my students have done this job and compared the computational fluid dynamics results with its output with respect to the experiments also, with respect to the observations also. And we found that there is a relation between the CFD results and with the experiments and observations is 87% is the agreement. So it works well with respect to the neural networks. So with now let me show you some of the work which is going on apart from my lab, like MIT, what they are telling. So you can see here they want to work with mind and hand. So they our mind and hand philosophy, the basic whatever we are thinking, that is the thing which I started. That is known as mathematical thinking. How we are putting that with respect to our hand. Philosophy spurs real world engagement, and thanks to the MIT's entrepreneurial culture, Greater Boston's innovation ecosystem brings with companies spun out of MIT. So whatever they are giving out, the research or whatever technology they are giving out, these things are connected with this, with the ecosystem, with the culture, and with the companies also. So one of the work which I have taken from their website, it is freely available. You can also see that machine learning model that helps determine protein structures. New technique reveals many possible conformations that a protein may take. So I want to show you this for a few seconds. One of the graduate student has worked in this. She is presenting. Yeah. So she will tell about this. showed you. So protein structures. So Professor Simons, professor of mathematics at MIT, head of the computation and biology group. So these are the groups together. They worked and they revealed this. So and shell modeling. This is also very beautiful idea in UK, Oxford, UK. They started working this and they want to show mathematically how the models are so adventures in mathematics. He gave the title adventures. Yeah. And coming to the policing department also, Harvard University has taken up some of the works and they mathematically presented that also. Here is only audio is available.
Excuse, excuse me, madam. It's not audible.
Oh, okay. Yeah. Okay. Yeah. Okay, sir. I am sorry for that. So I can show you that from this video. You can see that in criminal justice also, they are using mathematical models to get some of the identities or outcomes. How that data is revealing what type of structures they want to see in that one. So especially in Harvard University, totally one set of group of people, mathematicians are working in this type of models. So apart from that, in geomechanics, inside the earth, how the fluid flow is taking place, that also I have, along with other scientists collaborated, when it is getting heated up, the bottom layer is getting heated up, the fluid is slowly moving up because of the density variation. And when it is simulated, it showed such type of rectangular structures. As the starting of this lecture, they said about our Nobel laureate Chandrasekhar has said in his works that there can be a rectangular structures in the heating up of the plane layer flows, and through computers by solving the equations whichever I showed earlier with this initial and boundary conditions, we have solved, and exactly we can able to reproduce such type of rectangular structures. And this geomechanical people, especially geophysicists, has appreciated, and this has happened exactly the numbers which was given by Professor Chandrasekhar in the year 1961, and this is Chandrasekhar number 2000, and this is Rayleigh number which deals with the thermal forces, how much heat is giving up and how it the flow can be dealt in this one. So the colors are given in terms of the temperature, and these lines are nothing but the velocity lines, the fluid flow lines. So coming to the next slide, yeah. So coming to the industry, how mathematicians are recognized in industry. General Motors, Women in Science and Mathematics Award winner in the Department of Statistical Sciences. Her research has been applied to uncover causal relationships from large-scale observational data sets arising from genetics and medical studies. You see, again, she has told about the observational data sets. The previous things with respect to the human also, they got some type of data or model. Now, from the observations also, you will get the model. So this award has been given to her, Yunzu, third year PhD student, focusing on the statistical theory and applications. And General Electric CEO Jeff told Business Insider CEO that his major math major and participation in team sports better prepared him for day-to-day problems. His math and team sports has prepared him for day-to-day problem solving than his MBA. Okay, then this slides I will share with you. You can see his interview here. Openly, he admits that his math skills have helped him a lot. Then coming to the financial mathematics, now a booming technology is happening here with respect to the financial mathematics. So mathematics has been categorized into two types. One is pure mathematics, the other one is applied mathematics. If you go to Clay Mathematical Institute, you can see a list of $1,000,000 problems. List of 7 problems they have listed here. With over the decades, they can't be solved. The exact solutions are also not available. Even if they look very simple also, we can't able to solve them because of their non-linearity. So that type of problems have a major role in these areas. Like some of them we have seen: computational biology, physical applied mathematics, computational science, numerical analysis, theoretical computer science, theoretical physics. So in this way, we broadly categorize mathematics into these things. So what is the need? Overall idea I want to conclude now. So the need is address the problems of humanity, including sustainable energy, urban resiliency, fresh water, food for all, cancer, Alzheimer's and infectious disease. Now we are seeing this infectious disease corona, and a lot of contributions has been made in this. So, and along with that, technology also playing key role, like computer science. That and all we have seen just now. Translate new science into transformative innovation. So, in a correct manner, that is the more need for the technology. So, from clean water technology to medical research, everywhere, the modern science has a role. So finally, this is a quote I copied from the internet again. No one was ever really taught by another. Each of us has to teach himself. The external teacher offers only the suggestion which roses the internal teacher to work to understand things. This is from Swami Vivekananda's quotes. Okay. So this is the overall idea I want to project for this lecture. So if you have any questions, welcome.
If you have any questions, you are supposed to post it in the comment box. That will be taken into consideration. Any queries from your side? Just post it in the comments box.
How can we convince a student being first year to learn mathematics?
Okay, I'm sorry for not audible in the videos. Instead of I am telling the others work, I felt that I should show you whatever they are talking, whatever they are telling about their own work. That's why I prefer videos.
Thank you. Please tell.
We have a very simple question coming up now.
Yeah, please.
How to convince the first year students of BE to learn mathematics?
Yeah, you have to learn the basic mathematics. Whatever is available to you. Like if you want to learn the English language, first we should learn the alphabets, then words. So whatever you are learning in the first years, it's like alphabets and words. So if you want to build up a sentence or a paragraph, or if you want to write an essay, so the basics are necessary. That's what you are doing now. So at the end, what you are going to see, that's what I have projected in this lecture. If you have the strong foundation, then you can build over that.
What will
That's
be the
what
future of
my
the
message.
forecast?
Thank you so much, ma'am. Any more queries from the faculty side?
What will be future of Pascal and Fortran?
Yeah, one more
Future
question
of
coming up. The future of Pascal and Fortran. Okay.
Yeah, Fortran still I'm using it. I should say one more thing that I have started my career in Hong Kong Jockey Club. In Hong Kong Jockey Club, betting systems. They're still now they are using Fortran systems only. The program has been written, the code has been written in Fortran language. It is such a powerful language that no intrusions can come in, and it is also a very simple language to do the programming. So even for my some of my work, whichever I have projected here, I am using Fortran only. So it depends on us. You have the goal. You want to get the solution of that problem. How you are going to achieve that solution, it depends on us. You are going to use C language or C++ or Fortran. So, my opinion, Fortran is very easiest one compared to other languages in comparison for me.
Thank you so much, ma'am. So, concluding the bowl of soup, I thank our Honorable Secretary, Janab Zafar Jabi Sir, Sultanwa Education Society, our Advisory Director, Dr. Bashir Ahmed Sir, for his constant support and motivation to conduct the constant webinars on the National Science Day. I thank our respected deans in GCET, principals of all the constituent colleges, heads, coordinators, our colleagues, and the students who have been given an active participation throughout the session. Last but not the least, without our technical team, this program would never be a very buttery one. So I thank Ahmed sir and Mohidin sir for the constant support for technical. I thank everyone for joining us and making this webinar a very successful one. Thank you now once again for your valuable talk and giving us your motivational lecture on role of mathematics in emerging technologies. Thank you once again. We'll conclude the session.
Yeah, thank you.
Thank you.